G'day everyone, it's Rob Timmings from ECT for Health here with another Knowing Your Jargon. This is part 2 of our 8-part series on respiratory physiology, or the physiology of respiration. In our first episode, which you may have caught or maybe didn't we had a look at the FiO2 and how that was different from the percentage of oxygen. In this episode, we're going to be similar. We're going to be looking at the difference between the pressure of oxygen in the air that you're breathing versus oxygen percentage. And this has a lot of relevance when we start to talk about things like blood gases. So let's get things started. The oxygen percentage, as you will recall, is 21% of the air that you're breathing is oxygen. In other words, if you were to breathe 100 parts of air, 21 of those parts would be oxygen. And in our first video, we suggested that maths calculates out to 0.21. This is called the fraction of inspired oxygen, 0.21. Now we need that number to be able to calculate the pressure of oxygen. Now the pressure of oxygen is how much air pressure is on the Earth. 21% of the air pressure on planet Earth would therefore be oxygen. But it's a bit more complicated than just saying that. So let's have a look at planet Earth. So we've got ourselves sea level. So we would call that 0 meters because it's at sea level. And then we've got land, and that land may be anything up to the tallest mountain. So here we've got a tall mountain, and let's call this Mount Everest. And we've got, here's little Frank, and Frank is sitting, I'll just get rid of this, that's in my way. Okay, so here we've got little Frank, and Frank is sitting up on the top of Mount Everest. He is at 8,800 meters above sea level. Now, at sea level down here, if Frank was standing down here at sea level, and if you haven't met Frank, let me get Frank for you. This is Frank. So you can see why I drew him in red. So I'll let Ray look after Frank. It's kind of creepy. There we go. Ray can look after Frank. So Frank is at sea level down here, and we know that the atmospheric pressure at sea level on planet Earth, in the pressure units of measure of millimeters of mercury, is 760 millimeters of mercury. That is the air pressure. Sometimes that's called millimeters of mercury, sometimes it's called hectopascals. So the equivalent 760 millimeters of mercury, if you calculated that or converted that into hectopascals, that's around about 1,000 and, memory serves me right, about 1,014 hectopascals. Together, all of these are also called 1 atmosphere. In other words, sea level is considered to be 1 atmosphere of pressure. But as I go up in altitude, let's say I went to the roof of the world, where Frank is sitting up here on the top of Mount Everest at 8,800 meters, then the atmospheric pressure actually drops. And the atmospheric pressure drops to around about 0.3 of an atmosphere. In other words, 30% of whatever the air pressure is down here at sea level, it's only about 30% that air pressure up on the top of Mount Everest. So in millimeters of mercury, if at sea level our millimeters of mercury is 760, on the top of Everest it's going to be about 250. So you can see it's much, much lower than sea level air pressure. So we're going to use that air pressure at sea level to do this calculation. If oxygen equals 0.21 of air, in other words 21% of air is oxygen, then that must mean that if air pressure is 760 millimeters of mercury, oxygen must be 0.21 of air pressure. And if we did that maths, we would find this number to be 159.6 millimeters of mercury is the pressure of oxygen in the air that you're breathing. So when the doctor next asks you how much oxygen is the patient breathing, you could be clever and say they're on room air. That would be true to say. You could be very clever and say they're breathing 21%. You could be exceptionally clever and say an FiO2 of 0.21. Or you could be a real smarty pants and say they're breathing a PO2, a pressure of oxygen, that is 159.6 millimeters of mercury. Those values are going to be important in later sessions when we start to have a look at blood gases. See you next time. Bye.